the difference quotient of a function is going to give us the rate of change of a function. And depending on what function we're looking at, our answer may just be a number if it's a really simple function, or our answer may be another function that we get out. Okay? The formula that we use for the difference quotient is f of x plus h minus f of x all over h, where h cannot be equal to 0. You may be wondering, where does this h come from and what does it mean? It's just another variable here, and what it actually is the amount that we can change x. So we're changing x by some small amount, subtracting the original function, and dividing by h. Okay, and so what our goal usually is when trying to figure out the difference quotient is plugging in the two things into our formula in the numerator that's asked for, and then simplifying somehow and getting rid of the h. Okay? And so we need two things. We need f of x plus h, and we need our original function f of x. And when we plug in our original function, you need to make sure that you don't forget that you're subtracting it. So whatever you plug in right here, whether it's one term, you know, that would be okay. But if it's 2 terms, 3 terms, 4 terms, something like that, then you need to put it in parentheses because you're subtracting it. You know, even if it's one term and it's negative, you need to make sure you put it in parentheses so you'll remember to change the sign. Okay, so let's work out a problem using the difference quotient. Let's say that f of x is equal to 2x plus 5. The first thing that you need to do is you need to find f of x plus h. Alright, so we're going to take that function, f of x, and we're going to plug in an x plus h in parentheses for every x. Alright, so I'm going to take this right here, this expression, and I'm going to plug it into f for every x. And when I plug it in, I'm going to put it in parentheses. So I'm taking this part right here and I'm plugging it in right there. So this is this is 2 times x plus h plus 5. Alright, so this is 2x plus 2h plus 5. Now we just solved or found f of x plus h. And this part here that I have highlighted, we're going to plug in right here in our formula. Now also in our formula is minus f of x. So f of x, this right here, we're going to plug in right here. And we're going to put it in parentheses because there's a minus there. Alright, I'm going to write it here to the side. So 2x plus 2h plus 5, that was my f of x plus h, then minus f of x is 2x plus 5, so minus 2x plus 5 all over h. And so what our goal here is to do any type of algebra that we can so that we can cancel the h out in the denominator. Okay, so Let's distribute this negative sign, and I have 2x plus 2h plus 5 minus 2x minus 5 all over h. Alright, now notice that if I look at for like terms, I have a positive 2x and a negative 2x. Those cancel out. I have a positive 5 and a negative 5. Those cancel out. And I'm just left with what? 2h over h. And so now I can cancel the h's out, and I'm just left with 2. So the rate of change of the function 2x plus 5 is 2. Let's look at a little tougher function. Let's say that I had f of x equals 3x squared plus x plus 5. Okay? And I wanted to evaluate that in the difference quotient. I'm going to write down the formula one more time. It's f of x plus h minus f of x all over h. Okay? So the first thing I need to do is find f of x plus h. And the way that I do that is I take and I plug in parentheses for every x, x plus h. Alright, so let's see what's going to happen. 3 times x plus h squared plus x plus h plus 5. Now, we have to follow our order of operations. We cannot multiply this 3 on the outside times everything on the inside because of this power. We have to do the power first, exponents. Alright? And so, what does that actually mean? That means x plus h times x plus h. That's what x plus h squared means. Now there's no number in front of this parentheses, and there's a plus there, so I can just drop those parentheses. That's going to give me plus x plus h plus 5. Now I still have to simplify this, and I can't multiply anything in yet before I multiply my binomial times my binomial. And how do I multiply those two? I FOIL that out, right? So multiply the first terms. X times x is x squared. Multiply the outer terms. X times h will be a 1 xh, right? X times h, they're both variables, so it's just 1xh. Then h times x, that's hx, or the same thing as 1xh. And then multiply the last terms. H times h. That's going to give me h squared. Alright, so that's this thing folded out. First, outer, inner, last. Then plus x plus h plus 5. Now that I have folded that, I can now distribute the number on the outside. Before I do that though, notice that 2 of these terms in the parentheses are like terms. xh and xh are like terms. So if I put a 1xh and a 1xh together, that becomes a 2xh. So let's just pretend that I have written here just plus 2xh. So now I need to distribute this 3 to these 3 terms here. So that's 3x squared, and that's going to be plus 6xh, and that's going to be plus 3h squared. And then I have what? Plus x plus h plus 5. Alright, so you can see if you have a quadratic, finding f of x plus h takes a little while, because you have to plug in an x plus h in parentheses for every x. So now, let's take what we found for f of x plus h, all this right here, and let's plug it in right here in my formula. Then I'm going to take f of x and I'm going to plug it in parentheses right here with a minus in front. Okay? So I'm going to rewrite all this stuff one more time. 3x squared plus 6xh plus 3h squared plus x plus h plus 5 minus my original function, which was 3x squared plus x plus 5, and that's all over h. When you get to this step, it's important that you don't try to do something like this. Don't try to cancel that out, because that doesn't work. You can't cancel things out like that. Alright, you can't just cancel it out unless there's a product up top. Okay? The next thing we want to do is distribute this negative. So you want to multiply all of these terms by -1. So that means this first term is going to become what? Negative 3x squared. And this is going to be negative 1x. And this is going to be minus 5. Alright, if I distribute that negative to everything, then I can make this a plus. Alright, now here's something that's always going to happen as long as you have a function that doesn't have any fractions or something like that. Whatever you have here after you've distributed is going to cancel stuff out here. That's just the way that it works. Okay, so I have a positive 3x squared, a negative 3x squared. I have a plus x and a minus x. I have a plus 5 and a minus 5. So all of those are always going to cancel out some stuff over here. That leaves me with 6xh plus 3h squared. Right, that's my numerator. My denominator is h. Now, again, do not try to cancel out like this. Don't try to do that, because you have to have a product up top in the numerator to cancel out. So, since they both have an h, we're going to be able to factor an h out. So this has an h to the first, and this has an h squared. I forgot the other h. I did. Plus h. Sorry. Thank you. Yep. This little term right here does matter. And don't try to do this. Don't try to cancel out like this, because if you do, you know, it'll be wrong. You can't cancel out like that. You have to have a product. So all three of these terms then have an h. So let's factor an h out of the numerator and see what that leaves us with. We'll have 6x plus 3h plus 1. Now that I have a product in the numerator, I can cancel the h's out, and my answer is 6x plus 3h plus 1. It's kind of a strange answer because it has an h in it and we really don't know what h is, but that would be the answer. That's the difference quotient. That's the rate of change of the quadratic. Alright, so you take a minute and see if you can do one. Alright, let's say that we had the function negative 2x squared plus 3x minus 5. Alright, and we want to find the difference quotient of f. That's f of x plus h minus f of x all over h. So first start working on f of x plus h. I'll give you a few minutes to do that. So I'm going to work out f of x plus h now, and then stop there. Make sure you have the right f of x plus h. Make sure I get it right. So plug x plus h in parentheses for every x. And make sure you put that square there. I'm just gonna, we've already done that, so I'm just gonna write down what it was equal to. Now we distribute a negative 2. There's f of x plus h. So now plug that in your formula. See if you can get things to cancel out. Here's, I'm going to plug all this in the formula now. It's negative 2 x squared minus 4 xh minus 2 h squared plus 3x plus 3h minus 5, and now I'm subtracting the original function. So it's minus, and then in parentheses, negative 2 x squared plus 3x minus 5. And that's all over h. Alright, so now distribute the negative, or the negative 1 that's on the outside, to everything on the inside. When you do that, that's going to make this a plus, it's going to make this a minus, it's going to make this a plus. After you've distributed those, then you could make that a plus in the front, after you've distributed that negative 1 to everything. Now this is where stuff should cancel out. So I have a negative 2x squared and a positive 2x squared. I have a plus 3x and a minus 3x. I have a minus 5 and a plus 5. Alright, so let's write everything that's left down. So in the numerator I have negative 4xh minus 2h squared plus 3h all over h. Alright, so now I need to figure out a way to get rid of this h. Well, all three of these terms have an h to some power in them. So I can factor an h out of all three of the terms in the numerator. That'll leave me with negative 4x minus 2h plus 3 all over h. Alright, so now the h's cancel out, and that leaves you with negative 4x minus 2h plus 3.